we now discuss the solution of the problem from the section Quadratic Equations, and this question has appeared in Joint Entrance Examination Main held on 24th June 2022 in the first shift. The problem is, if the sum of the squares of the reciprocals of the roots alpha and beta of the equation 3x square plus lambda x minus 1 is equal to 0 is 15, then 6 times alpha cube plus beta cube whole square is equal to, we are given 4 options. Option A 18, option B 24, option C 36, option D 96. We are given a quadratic equation 3x square plus lambda x minus 1 is equal to 0, and alpha and beta are the roots of this equation, and it is given the sum of the squares of the reciprocals of alpha and beta is 15. Then we have to find 6 times alpha cube plus beta cube whole square is equal to from the given 4 options here. We will now discuss the solution of the problem in detail. We have the quadratic equation 3x square plus lambda x minus 1 is equal to 0. We are given alpha and beta are the roots of this equation. Therefore, sum of the roots alpha plus beta is equal to minus the coefficient of x by the leading coefficient, that is 3, that is minus lambda by 3. And the product of the roots alpha beta is equal to the constant term minus 1 divided by the leading coefficient 3. So alpha beta is minus 1 by 3. And we are further given the sum of the squares of the reciprocals of alpha and beta is 15. That is 1 by alpha square plus 1 by beta square is given to be 15. And simplified like this, alpha square taken the LCM, alpha square plus beta square by alpha square beta square is equal to 15. For alpha square plus beta square, we have written alpha plus beta whole square minus 2 times alpha beta by alpha beta whole square is equal to 15. So now writing down, for alpha plus beta minus lambda by 3, for alpha beta minus 1 by 3, we get, and we have sent this alpha beta whole square to this side. That will be, when that is 15 times alpha beta whole square, that is 15 times minus 1 by 3, and alpha plus beta whole square minus lambda by 3 whole square minus 2 times alpha beta minus 1 by 3. When simplified, you will get lambda square plus 6 is equal to 15, and that will imply lambda square is equal to 9. Now, required to find 6 times alpha cube plus beta cube whole square, and that we will write it as 6 times in brackets. For alpha cube plus beta cube, we have written alpha plus beta whole cube minus 3 times alpha beta into alpha plus beta, and there is a square. Now write down for alpha plus beta the value minus lambda by 3, for alpha beta minus 1 by 3 you write down, that is 6 times minus lambda by 3 whole cube for this minus lambda by 3 we have written. Why? 3 times alpha beta is how much? So alpha beta is minus 1 by 3. 3 times alpha beta is minus 1. There is a minus 1. Minus into minus plus 1. Plus alpha plus beta into alpha plus beta. Alpha plus beta is minus lambda by 3. So it results in minus lambda by 3. Agreed. And 6 times minus lambda by 3 taken out as a common factor. Then 6 times minus lambda by 3 whole square into, in brackets, we are left with lambda square by 3 square, that is 9 plus 1. Yes. Now lambda square is equal to 9. Lambda square by 9 is 1. And this will be minus 1 whole square, that is 1 only. And lambda square by 9 that is 1 only. 1 plus 1, 2 square. So that is equal to 6 into 1 plus 1 whole square. That is 6 into 2 square. 6 into 4, that is 24. So the value of 6 into alpha cube plus beta cube whole square, this value is 24. Let's look at our options. Our answer 24 appears against option B. Therefore, our answer is option B. And that is the solution of the given problem on quadratic equations, and it is a straightforward question. It's not that difficult, and even any average student can attempt this question. I am sure that you have understood the solution of this problem, and go on working out some more problems from the section quadratic equations. I wish you all the best. Thank you.